Basically, the same used to be the goal of 3D generation. Now it's just the baseline. Today's models give you the right object, the right shape, the right look. But is it technically the same object as the one in your image? Can you still read the text, word for word? Is the face still the same person? Do the patterns keep their exact shape and spacing? At this level, almost right is wrong. That's Twinkle3D. One image, one geometric twin. Watch this car. Multi-shell. One voxel forced to hold several disconnected surfaces, and they cut through each other. Holes. Nothing guarantees the mesh comes out sealed. Thin shells. Walls too thin for the representation to hold, and the geometry breaks apart. None of these are generation errors. They're inherited from the representation itself. Object-specific fidelity can't be added back at the end of the pipeline. It has to survive compression before generation even begins. The representation sets the ceiling. The VAE decides how much survives. Discard thin walls and sharp edges at encoding, and no model downstream can bring them back. Hi3D 1.0 Spark 3D showed compact latents don't have to sacrifice geometry. Accurate reconstruction at 8 times compression. OVoxel in Trellis 2 moved beyond SDF and pushed further. But even the best still fails the way you just watched. Twinkle3D solves all three at the system level. Same inputs, side by side, the fidelity of 2048 cubed OVoxel, with meshes that are watertight and printable. The details hold. Reconstructing at 2048 cubed is one problem. Generating from a single image is another. In generation, detail is paid for in sequence length. 20,000 tokens. 50,000, 200,000. The difference you're seeing is sequence length, and at 2048 cubed, a single training sample reaches 300,000 to 400,000. For a standard DT, that length drives up everything: compute, memory, communication, throughput. Run it naively, and one training step takes about 10 minutes. Nothing crashes. Training just never converges. Twinkle3D's answer was joint design. Computation reorganized at the model level. Distributed training optimized at 1,000 GPU scale. Same sequence length, a fraction of the overhead. 10 minutes per step became 10 seconds. That turns 2048 cubed from a resolution the representation can merely hold into one the model can actually learn. Since Trellis, 3D generation has typically been multi-stage. Coarse shape first, details later. But refinement cannot fix errors in curvature, thickness, or spacing. It only sharpens them. Twinkle3D targets accuracy from the start. One stage outperforms a two-stage pipeline with 512 cubed refinement, providing a stronger foundation for 2048 cubed generation. Crowded scenes come out complete. Text, engravings, and fine reliefs survive. Even on complex objects, fine structures stay clear and stable. Remember the questions this started with? The text can still be read. This is Twinkle3D. One image, one geometric twin.